15 tons. Now, let's take a look at how such a massive machine achieves the incredible feat of vertical takeoff. In the footage, the Boeing 787 appears to climb at an astonishing vertical angle, but it's actually just a visual illusion. So far, commercial airliners still cannot achieve true vertical takeoff. Even so, seeing such a large and heavy steel beast climb at a steep angle is breathtaking. So how exactly does an airplane take to the skies? Today, I'll walk you through the entire takeoff process of an airliner using an animation with the Boeing 787 as our example. The principles of flight begin with the wings and tail. Upon closer inspection, you'll notice that these surfaces are not a single solid piece. They consist of several movable parts. These parts can open and move, and they are all designed to follow aerodynamic principles. Take the wing, for instance. It has an upward curving arc shape, thicker at the front and thinner at the back. This shape helps cut through the air as the plane moves forward, generating a downward airflow that creates a pressure difference between the top and bottom, producing lift. However, lift alone isn't enough to get the plane off the ground. The lift generated by the wings must exceed the plane's weight for it to fly. So, how does the airplane increase lift? There are three methods. 1. Increase the angle of attack. The higher the angle, the more airflow underneath and the greater the lift. 2. Increase the aircraft speed. More airspeed significantly increases lift. 3. Change the shape of the wings. Altering the wings configuration can increase airflow and surface area, boosting lift. Now, let's apply this knowledge to a plane. When we activate the wing flaps and slats, they increase airflow and generate more lift. Ailerons can move up and down, which respectively decreases and increases lift. At the rear of the plane, there are two key components, the rudder and the elevator. Adjusting the elevator controls the vertical force at the tail, while the rudder controls horizontal forces. Next, let's see how these components work during the airplane's takeoff and climb. Back to the footage of the Boeing 787 taking off. To lift the plane off the ground, the pilot uses various techniques to increase lift and ensure it exceeds the plane's weight. First, they increase engine thrust to raise the aircraft's speed. Once the speed is high enough, the pilot activates the wing flaps and slats to boost lift further. When the plane is ready for takeoff, they engage the elevator, tilting the tail, and the angle of attack increases. This suddenly boosts lift, allowing the plane to take off smoothly. We notice that during takeoff, the engines play a crucial role in increasing speed. So, how do they generate thrust? By burning more fuel, the pilot increases thrust. Next comes the climb phase. As long as the engine's thrust exceeds drag, the airplane's speed continues to increase. The greater the speed, the greater the lift, and the plane will keep climbing. When the plane reaches cruising altitude, thrust should equal drag, and lift should exactly counterbalance the plane's weight. At this point, some of you may wonder, how does the plane turn while flying? The aircraft is equipped with a rudder that generates horizontal force for turning, but directly changing direction like this can cause discomfort, so it's not practical. Instead, pilots use centrifugal force to turn the aircraft. The pilot simply raises the right aileron and lowers the left one. The difference in lift between the wings causes the plane to bank, and the horizontal component of lift generates the necessary centrifugal force, allowing the plane to turn. However, this banking technique has some drawbacks. When the plane holds one aileron up and the other down, there's an imbalance in drag between the wings, leading to a phenomenon known as adverse yaw. The rudder must be used simultaneously to correct the plane's course. When the aircraft reaches its destination, the pilot reduces engine thrust and keeps the plane's nose down for descent, performing the reverse of the climb. As the plane prepares to land, it slows down and the wing flaps and slats are re-engaged. These devices increase drag and help slow the plane down more quickly. The reverse thrusters are deployed, redirecting air forward and aiding in stopping the plane faster. If you found this explanation fascinating, don't forget to hit the like button, share it with your friends, and subscribe to our channel for more awesome aviation insights.